So this one is rate of reaction exercise 2. You can use your mic or a chat to state the answer. The first question itself is related to the experiment which we already discussed now about the reaction of sodium thiosulfate with hydrochloric acid. So when aqueous sodium thiosulfate is there mixed with hydrochloric acid, a precipitate form. If they ask what is a precipitate, so or definition of a precipitate, so precipitate is a solid form when by mixing two solutions, that solid is known as a precipitate. In short, you can write PPT. So even in exam, it is acceptable. Some places, if you want to write the precipitate, you can write in short PPT. Actually, when we mix them together, they will react. So it's first we mix them together and then the mixing will lead to reaction. It's not a physical change, it's a chemical change as a new substance is formed. So when sodium thiosulfate react with hydrochloric acid, it will result in a formation of a sulfur, sodium chloride, water, and sulfur dioxide. The time for the cross to disappear from viewing is measured. Like we measure how much time the cross will take to disappear. As you can see, the table is given to you. A student add the following volume of thiosulfate, hydrochloric acid, and distilled water. The time for formation of a precipitate of sulfur to make the cross disappear is recorded. State the order in which we should add aqueous thiosulfate, hydrochloric acid, and water. What should be the order in which we should add these three substances? Here. What we should add first, second, and third? You can use your mic or a chat to state the answer. Which one we should add first? So water is not the reactant here. Water is just to make the final volume same so that the one which is having a greater proportion in the mixture will have more concentration or more particle. So the order in which we should react them, first we will add sodium thiosulfate. Then we cannot add hydrochloric acid. Why I cannot add hydrochloric acid? Because the moment I add hydrochloric acid to thiosulfate, they will start to react. So there will be no use of adding water at the end. So water should not be at the end. Either water can be there in the beginning, water can be there in the center, but it like in between, but it cannot be at the end. So we'll add sodium thiosulfate, the second we'll add water, and the third we'll add hydrochloric acid. This is one way. So this is 1, 2, 3. But water should not be there. Why can't we add at the end? Because water is not the reactant. The moment you add thiosulfate with hydrochloric acid, the reaction starts. So there will be no use of adding the water. Because to make the total for a fair comparison, to make the final volume same, water is added. So if you mix first you was having thiosulfate, then you had hydrochloric acid, so they will start to react with each other. Then what is the use of adding water at the last? That is totally wrong. That's why water should not be added. We should not add the water at the end. We can add water in the beginning. We can add water in between, but water should not be there at the end. So it can be other order. It can be water. Like we can add water. We can add sodium thiosulfate. And we can add hydrochloric acid. This will also work. Why? Because first water is there, then thiosulfate, and then hydrochloric acid. So it will work. But the order in which water is added at the last is totally wrong. The next part in experiment 3, student wanted a thiosulfate to be double concentration. Like he want a double amount compared to experiment 2. So if experiment 2, it was 20, I want a double amount. how much or what should be the volume of thiosulfate? You can use your mic or a chat to state the answer. How much thiosulfate should be added? Yeah, that's right. We need 40. Hydrochloric acid, because we are not changing hydrochloric acid, so it is still 10. Then how much water should be there? The total volume of the solution is 16 experiment 1, 16 experiment 2, so it should be 16 experiment 3 as well. Because the sum should be equal to 60. So how much water I should add? The amount of water should be 10, because 40 plus 10 plus 10, 60. 20 plus 10 plus 30, 60. 10 plus 10 plus 40, 60. Because the total volume of all the mixture in this experiment, it is 60. Now, if you want to work out the time, we have to complete the expected time. Look, if the amount is double, the time will be half. So how much time it will take? So it will take 14 seconds. Because the amount is double, if we increase the concentration or the concentration is twice, the time taken by cross to disappear will be half. That's why if 28 divided by 2, it will be 14. You can also compare the result with the first experiment. Like example, another student want to compare experiment 1 with experiment 3. So compared to experiment 1 in experiment 3, it is 4 times. So if the concentration or amount is 4 times, then this will be divided by 4. So 56 divided by 4, you will get 14, 1 4. So either you compare experiment 2 with 3 or experiment 1 with 3, you will get the same result. It does not make difference. In the next part, use collision theory, explain why increasing a concentration of sodium thiosulfate would change the rate of reaction. It's of 2 marks. So what are the points you will include? When we increase the concentration, there are more particles in a unit volume. Like there are a greater number of particles in a same space, which increase the number of the collision. So 2 points are there, 2 marks. So there are more particles in a unit space. You have to use the term in a unit volume, because if you increase the concentration, 1 mark for mentioning increase in concentration, increase the number of the particles in unit volume. That is one thing. What is the second point? Because there will be more particles in a unit volume, so they will have more collisions. A greater number of effective collisions. As a result, the reaction will be faster. So it is important, use the term unit volume, like more particle, but there are more particles, that's obvious, but in a unit volume, in a specific volume, there are more particles, which leads to more collision. Then student repeated the experiment 1 at a higher temperature. Use a collision theory why the rate of reaction increases. A 3 mark. So 1 mark, you will mention the particle will have more energy or particle move faster. That is 1 mark. Sometimes the same question is a 4 mark, but answer remain the same. So what are the points you should include? You will mention the particles have more energy or the particles are moving faster. So it increases the number of the collision, or greater number of the particles have energy more than activation energy. I'm writing a model answer here. So you should always use these points whenever you are mentioning how the temperature affect the rate. First thing, increase in temperature, increase the kinetic energy or speed of the particle. That is one point. Then as a result, there will be greater number of collisions or successful collisions. And the third point is greater number of the particles have energy more than activation energy. So these are the points you will always include. The same question, sometimes you will find it's of 3 marks, sometimes it's of 4 marks. When it is 3 marks, the same answer when we are writing for 4. But normally when it is of 4 marks, 1 mark increase in temperature, increase kinetic energy. Increase in kinetic energy, increase the speed. So these two are giving you 2 points. And then there will be more collisions or more successful collisions. And as a result, greater proportion of the particle have energy more than activation. So this is always a model answer. Whenever a question is there, how the rate of a reaction affected by temperature, you will always write these points. In the next question, magnesium carbonate is reacting with hydrochloric acid. It results in a formation of magnesium chloride, water, and carbon dioxide. So when they are reacting, a carbon dioxide gas is given off. We can use a gas syringe or we can use this method, because in this method we can observe the gas is released, so there will be bubbles, and we collect a gas here in the inverted measuring cylinder. An excess of magnesium carbonate. So this is whenever two reagents are there, one is excess. Excess means when the reaction finished, this will be left. So the other factor will be the other reagent will be the limiting reagent or limiting factor. Means if I change the limiting factor, it will affect the rate and it will affect the amount of product. But if I change the excess reagent, it only change the rate of reaction, but not the amount of product. They already mentioned in the question that magnesium carbonate is in excess. So obvious that hydrochloric acid will be a limiting factor. The results obtained are shown on the graph. You can see how we collect. 4-mark question that describe how the rate of a reaction changes during a reaction and explain why the rate changes in this way. First thing, rate of reaction always decreases with time. So what are the points you will include for such questions? In the beginning, you will have a maximum rate, but rate of a reaction always decreases with time. So for question 2, so the points here will mention the rate decrease with time. That is 1 mark. Then what is the second point? The first thing is rate decreases with time. The second point, because the number of the particle decreases or reduces. The first one, rate is decreasing with time. The second point, the number of particles, reactant particles decrease. The third point, there will be fewer collisions per second. Like every second, less number of particles will collide. And eventually the reaction stop. So if reaction stop, what is used up? Which reagent is used up? If this reaction stop. So if the reaction stop, which reagent is used up? The limiting reagent. And what is the limiting reagent? That is hydrochloric acid. So reaction stop because hydrochloric acid is used up. So why the rate is decreasing over a time? In the beginning, you was having more particles of acid and magnesium. Like black spots example are representing a magnesium and the red spots are representing, say, hydrochloric acid. when they react with each other, the amount of these reactant particle decreasing, like amount of magnesium is also decreasing and amount of hydrochloric acid is also decreasing. But eventually what will happen? There will be no more hydrochloric acid left behind. So the reaction has stopped completely. So if I mark the points here, like to show the graphical representation, what happened actually? In the beginning, we have more particles of the reactant. Say the red spots are representing magnesium, hydrochloric acid, and the black spots are representing magnesium. First, there are more particles, so they're colliding faster rate in the beginning. But then what happened, as they start to react, the number of the particles are decreasing. Both magnesium and hydrochloric acid, the number of particles decrease. And eventually what happened, we are left with only magnesium. There's no hydrochloric acid. That's why the reaction stops. So these type of questions, they give you a graph and they ask explain. So you will always explain in this manner. Don't say rate of reaction increase. If you say rate of reaction increase with time, that is totally wrong. Rate of reaction is only maximum in the beginning and it decreases with time. The next part, the experiment was repeated using a same mass of a powdered magnesium carbonate with the same volume and concentration of hydrochloric acid. We did not change anything, and only thing what we did, first we were having like pieces, now we are using powdered magnesium carbonate. So powdered magnesium carbonate will react much faster. So initial rate or the starting rate will increase. And what is the reason for that? Because the powder will have a large surface area. But what about the total volume? What about the total volume? Will it change? Total volume of a gas given off. So it won't change because even if we increase the amount of magnesium, the total volume does not change. So the total volume of the gas won't change even if we increase the amount of magnesium and use a powdered magnesium, because magnesium is an excess reagent. So total volume will be same. And reason for that, because we use the same amount of reactant. So if they ask sketch on the graph, if we use a powdered magnesium, so when you use a powdered magnesium, but same amounts are there, so the reaction will be faster, means it will be steeper, but the final product will remain same. Means this reaction will occur at a faster rate, so it will be much steeper, but the final product won't change, so it will be same. So this will be the graph for a powdered magnesium. Then we have a piece of magnesium ribbon was cleaned. The experiment was repeated using a clean magnesium ribbon instead of magnesium carbonate. The reaction is exothermic. Exothermic reaction give out energy. The rate of a reaction gradually increases. Why the rate of reaction increase? A 5-mark question. When you check the answer is not that difficult. First thing, so temperature increase since the reaction is exothermic. That is 1 mark. Then second mark, particle have more energy. Particle will move faster. They will collide often. No, it's not about purity here. You don't have to mention about purity anything. It's you have to relate the temperature. So first thing, increase in temperature, increase the kinetic energy or speed of the particles. That is one thing. Due to when the reaction give out energy, the particles have more energy, they are moving faster, like the temperature increases. So the particles have more energy, the particle will move faster, they will have more collisions per unit time, greater number of the particles have energy more than activation energy. So the points which will score the mark, 1 mark when you mention the temperature increase, that is 1 mark. Like here, when we mention temperature increase, that will give us 1 mark. Then the particle have more energy or increase the kinetic energy or speed, that is a 2nd mark. The more collision, when you mention increase the kinetic energy, increase the speed as well, that is 3rd mark. More collision per unit time, 4 mark. Greater number of the particle have energy more than activation energy, that's a 5th mark. So even though a question, it's a 5-mark question, but the answer is very simple. Increase in temperature, increase kinetic energy, increase speed, particle move faster, they will collide often, and as a result, more particles have energy greater than activation. Kinetic energy and speed are related to each other. Yeah, you have to mention unit time. If speed increase, kinetic energy will increase. But mentioning kinetic energy is one point, mentioning speed is another point. Another question, a student investigate the progress of a reaction between hydrochloric acid and excess of marble chips, which is calcium carbonate, using the operators shown. A hydrochloric acid and excess. So which one is a limiting factor here, limiting reagent? A marble chip, a piece of marble, or hydrochloric acid? Which one is a limiting factor? The HCl or hydrochloric acid, because they already mentioned a piece of marble is in excess. Excess means more than enough. So when this reaction will occur or happen, the solid will left behind because it is in excess or more than enough. So when we carry out this reaction, the marble chips are left behind. How does the shape of a graph shows that the rate reaction decreases as the reaction progress? Rate of a reaction is actually the slope of the line. So you can mention the slope decreases. That's why it shows that the rate is decreasing. The gradient decrease, the slope decrease, so rate is also decreasing. Why does the rate decrease? What is the reason for that? Why the rate of a reaction decreases? Because there will be like the amount or the number of the particle decreases. That's why, yeah, less hydrochloric acid, less collision, less particle. It's important that you mention less hydrochloric acid rather than calcium carbonate. Because hydrochloric acid is a limiting factor. That's limiting factor, yeah, less particle. But you have to specify which one less particle. So you have to mention less particle. You can mention less hydrochloric acid or less particles or decrease the number of particles of hydrochloric acid. If you just write less particle, it's not a full complete answer. It should be the concentration of the hydrochloric acid decrease or number of the particle of hydrochloric acid decrease. How many seconds did the reaction finish? How much time this reaction take to finish off? What is the time taken by this reaction to stop completely? So how to work out? Yeah, that's right. So how to work out? This is a point where the reaction appear like still it's a curve. But this is a point. If I zoom in, you will find when it becomes horizontal, that is a point where the reaction has stopped. So this is a point where the reaction is stopped. So 120 seconds. So 120 seconds time taken by for this reaction to stop. The experiment was repeated using a same mass of a smaller pieces of a marble. On the grid, we have to sketch a graph. If we are using a small pieces, it means they will have a large surface area. But we kept all the conditions same. What will be the shape of graph? You can use screen annotation to complete. If I use small pieces of marble chips, what will be the shape of the graph? You can use the screen annotation to complete. So it should be above, but one common mistake from students that they used to make it up and then down like this. That is wrong. Like it's not like volume increase and the volume decrease. It should be above. Anywhere you can draw above, but the final volume should be same. Another question means another part related to the original experiment was repeated using a higher temperature. 5 mark question. What are the points we'll include? Yeah, what are the points we'll include? Number one, if it will take less time for the reaction to occur, the reaction will be faster. Particles will have more energy. Particles will move faster. If when you mention more energy is 1 mark, moving faster or high speed is another mark. More collisions per second and greater number of the particle have energy more than activation. You have more successful collisions. So 1 mark, when we increase the temperature, the rate will increase. Then increase in temperature increases the rate. As a result, what will happen? More energy or more kinetic energy. The particle will move faster or high speed. There will be more successful collisions per unit time. And as a result, greater proportion or greater number of the particle have energy more than activation energy. So this is always these are always the points which you will include whenever you're answering a question related to temperature. So 5 mark, I think this is like a free mark. So you should not miss any point in these type of questions in which the answer is a straightforward. Then another similar reaction is there. A student investigate the rate of reaction between lumps of calcium carbonate and dilute hydrochloric acid. Student measure the volume of carbon dioxide gas. Which measurement should student make during the reaction to determine the rate? What student should do to determine the rate? So 2 marks. So two things he should measure. Number one, he should measure the volume of the gas. And number two, the time interval. Because to measure the rate, we always need the time. So volume of gas and time taken. 1 mark is for mentioning volume of gas and 1 mark how much time it will take to produce that specific volume. What happened to reaction, rate of reaction as a reaction progress? 3 mark. So first thing, rate of reaction always decrease. First, 1 mark is rate decreases with time. Then why the rate decreases with time? Because there will be less particles, less collagen, and eventually for these type of questions, as you can see, calcium carbonate is in excess. So hydrochloric acid will be the limiting reagent or a limiting factor. So we'll mention the rate decreases. The rate decrease as the reaction progresses since number of the particles are lower. And what about the third point? The reaction stop. So the third point, the reaction stop. Why the reaction stops? Because the hydrochloric acid used up. The limiting reagent, according to question, is hydrochloric acid, so it is used up. In question part C, a student repeated the experiment at a higher temperature, keeping all the conditions same. Explain in terms of collagen why. Sometimes the same question, same answer, 4 marks. Sometimes the same question, same answer, 5 marks. So you will mention the same points like increase in temperature, increase the kinetic energy of the particle will move faster, more collagen per unit time, and greater proportion of the particle have energy more than activation. Apart from higher temperature, suggest 2 methods to increase the rate. Other than changing the temperature, how I can increase the rate of this reaction? So what I can do? How I can increase the rate of this reaction? More concentration. That's right. Or I can use a powder, yeah, more concentrated acid, or I can use a powdered, this was which reactant? Powdered calcium carbonate. So one thing, I can increase the surface area. By using powder calcium carbonate. That is one thing. Second, what I can do, I can use more concentrated acid. So both will increase the rate, or I can also mention using a catalyst. So more concentration, surface area, or catalyst. But you have to mention any 2 out of the remaining factors. So these are some questions from exercise. A similar questions you will find every time a similar question is there related to this.